Just continuing from last lesson, exercise 4.8, example 27. We had already done a couple of these. We're just finishing them off. So example 27, product and quotient of functions. Here are my four functions, and we have to find the domain and range for these product or quotient functions. The first one is the function of x times g of x. Put them both in brackets because there's more than one term, and expand it. You should recognize this as a cubic function. Last lesson. So we know that those cubics, a positive x cubed graph, there's no discontinuity in it, and the domain will be all real x and the range will be all real y. Okay, and if you want, you can write it the way that you know, like this. Okay, now the second function was also a product of two functions. However, one is a square root function, and there is a restriction on the domain for the second function hx. So we know that x plus 4 must be greater than or equal to 0, therefore x is greater than or equal to -4. The first function has no restriction on its domain, but because the second one does, we have to go with that restriction for the product function. So therefore the domain, we looked at this before, was x is greater than or equal to -4, or if you want to write it in terms of the interval notation, it's -∞ up to 4. Now the range, so you can write it like that or like that. Now for the range, you have to look at your restriction of x. We know that the lowest value that x can be is -4. So we can say when x is -4, this square root of x plus 4 is what? 0, isn't it? Is 0. So therefore the value of the function will be, when x is -4, you'll get 16 plus 3 times 0, you'll get 0. So we know, that the function has a value of 0 when x equals -4. Now the values of x are now going to be greater than that, and as the values of x get bigger than -4, like -3, -2, -1, let's try 0. For example, if x was 0, we want to see now, are the values of x going to be bigger than 0 or smaller than 0? So we're just going to try another value of x that is greater than -4. I'm going to try just when x is 0. Mistake here, thank you. It's -4, positive infinity. What's probably good to do here, sorry, my mistake, is to draw that. That's what I would do. Sorry about that. Sorry. So you don't get confused, just do that. Do the sketch and then you won't make the mistake because it's from left to right. So the moral of the story is to sketch and then you won't make that mistake, all right? So when x is -4, the y value or the range, or the y value or the value of the function is 0. So I know that x has to be greater than or equal to -4. I'm going to try a value bigger than 4. Say when x is 0, my function becomes 0 plus 3, which is 3 times the square root of 0 plus 4 is 4. 3 times 2 is 6. So it appears that y will be greater than 0 will be my range. See, because I got y was 0 and then I got y was 6, if I look at other values, I'm going to get higher values because, see, this is only going to get bigger and bigger as x gets larger. And this is going to get bigger as x gets larger. So it makes sense that it'll just be going up. So the range is y is greater than or equal to 0, which is, if you sketched it like that, or 0, infinity. Okay, now for function c, these are the tricky ones. You just have to be very careful with these. It's function of x over g of x. Now, so function c, function of x over g of x, is x minus 5 over x squared plus 3. So we have to look at domain and range. What determines what, if there are any restrictions on the domain? Is it anything about the numerator or something about the denominator that makes you think, well, this value of, you can't have this value of x? It's the denominator. So denominator can't equal 0. But you know what? The denominator will never ever be 0 Remember we started this last lesson? Because x squared is always positive or 0, this will never be 0. So if you try to solve x squared plus 3 is 0, you get x squared is negative 3. That has no solution. So therefore, the denominator is never 0. Denominator cannot equal 0. So that means there are no restrictions. All values of x are allowed. So therefore, the domain is all real x. Now, we good with that? Now we've got to look at the range. Now, what's going to affect the range is, are we only going to get positive values for this or negative values as well? So let's have a look. Do a positive value of, look, what if x was, say, 0? What would you get? Negative 5 on 3, that's negative. So y can be negative. Do you see that? What if x is negative 5 or something? You get negative 10 on negative 5 squared is 25. Negative 10 on 28, that's another negative value. So y can be negative. Can y be 0, girls? What if x, what would make y 0? What if x is, no, 5. The numerator is allowed to be 0, but the denominator can't be. So if x was 5, I get 5 minus 5 is 0. 0 over 28 works. 0. So I've got negative y's. I've got y equals 0. And what if I choose a nice big value of x like 10? I get 10 minus 5. I get 5 over 103. Positive values of y. So it appears that the range could be, the y values can be negative. They can be 0. They can be positive. What do you think we should put? Range is all real y. Now that's the best you can do unless you know how to sketch it and find maxima and minima. Okay? All right, so our range is all real y. Let's look at our next one. What have I got? Example 27. What was it? K of x over function of x, which is x cubed minus 2x squared plus 6 over function of x is x minus 5. Okay, let's look at domain and range. So you can tell what the domain is going to be by just looking at the denominator. No restrictions on what the numerator could be, but there are restrictions on the denominator. What can x not be? 5. Domain is all real x. X cannot equal 5. And how do we write that now? New method. Negative infinity, 5. Union, 5. Positive infinity. And now let's have a look at the range. Now, there's no reason why the numerator can't be 0. I don't know what value will give me 0, but there is no reason why it can't be. So what we're going to do, let's just look at, we know that x can't equal 5. Let's look if x was greater than 5. What would you get if x was greater than 5? Let's say if x was 10, what would you get? Oh, something big. You'd get, so let's have a look. If x was greater than 5, would I get a positive or a negative number down here? K of x over function of x. We want to see if it's positive or negative. You could put it into your calculator, or you can just use common sense. If x was greater than 5, wouldn't the denominator be negative? A positive? Yep. So we've got a positive. And if the denominator was greater than 5, let's say something like 10 or something, you'd get 1,000 minus 200 plus 6. That's definitely positive. But you can try something like 6, 216 minus 72 plus 6, definitely positive. So, you know why? Because the x cubed is always going to be bigger than that x squared. Do you know what I mean? That x cubed is always going to be bigger than that 2x squared. All right, so if x is greater than 5, your numerator will be positive, your denominator will be positive, which means that your answer is going to be positive. Got it? You can't do if x equals 5, but we can do if x is less than 5. Let's try if x is 0. What would you get? If x is 0, what would you get? You get 6 on negative 5. You would get a negative answer. You'd get a negative. And let's just do if x is like, I don't know, something really big and negative. Doesn't matter, negative 10 or something. We're just trying a negative value. That would be negative, wouldn't it? The denominator would be negative. Look, this is negative 1,000. That would be positive 100, the x squared. I think the numerator is going to be negative as well. What do you think? So we've just shown that we can have a positive value for y for the function. We can have a negative value for the function. We can have a positive value for the function. What would you now say? That you think y is going to take on all real y. So range, we're thinking all real y. There's no reason why you can't get x is 0, because there will be some value of x here that is going to make that 0. We just can't work it out. It's too hard. Okay? Example, if x was 4, 4 cubed is 64 minus 32 plus 6. That's positive over negative is a negative if x was 4. All right? So you can get positive values, negative values, and you actually can get 0. You can get 0 for this, but not from the denominator, but from the numerator, definitely. Okay? All right, so it's all real y for your range. And the last one, h of x over f of x is the square root of x plus 4 over x minus 5. Let's look at the domain and the range. Now, okay, what do you think? Domain. Are there any restrictions? There's 2 restrictions. So tell me what you know about the x plus 4. This is what I've got. That x plus 4 has to be greater than or equal to 0. So x has to be greater than or equal to negative 4. But what's the domain telling me? It's not the domain, the denominator. X minus 5 can't equal 0, so x can't equal 5. So this is what I've got, that x has to be greater than or equal to negative 4, but it can't equal 5. So how do we write that? That, it lies, I'm going to sketch it. Here's negative 4, it can be bigger than that. Once, and here's 0. And when I get to 5, it can't equal that, but it can be bigger than 5. So I've got an open hole at 5. So I've got a closed hole, a closed circle at negative 4. I can go bigger than 4. Would have been all the way, but I've got a gap at 5 because x can't equal 5. So I've got an open hole. So this is a straight line here. So what have I got? That my domain is, let's do it both ways, the way we used to write it and the new way. That at negative 4, do one part, go. You could just do that it's greater than or equal to negative 4, but x can't equal 5. Or you could do x lies between negative 4 and what? 5, comma, and x is greater than 5. You can do that from there to there, and x is greater than 5. X can't equal 5. Are you okay with this, girls, or not really? Are you okay with, we did have x is greater than or equal to negative 4, but we had a problem. X cannot equal 5, so I've got to put a circle there. So do it in 2 parts, from negative 4 to 5 with the less, ooh, no wonder why you're looking at me strange, girls. There's no less than sign. Didn't see that. And x is greater than 5. Are we better now? Yeah, say something, girls, please. So, negative 4, comma, how do I write it? 5, bracket, 5, comma, infinity, union. All good? All right, that's enough on this stuff. 4.8, question 10. I just wanted to look at that one because it's going to tie in with what we're doing next, okay? So, if it's a bit different, function of x is x plus 4, and g of x is x squared minus 16. You have to find the following. First one's fine, function of x times g of x, no problem. B, and we want domain and range, okay? G of x over function of x is next. And then for C, we're going to do function of x over g of x. So this is question 10 from the exercise. Now, first one should be fine. I want you to expand and tell me what type of function you think you've got. Actually, you'd even actually be able to sketch this, so don't expand it. Yes, it's a cubic. I don't want you to expand. What I want you to do is factorize the second one for me. Good. I'll do x plus 4 first, x minus 4 second. How do I write this? Yes, x plus 4 squared, x minus 4. Definitely a cubic. Remember this, good revision for last year. So you tell me where it cuts. Yes, and? Oh, lovely. So it bounces. This is a double root at -4. See how it's the squared? It's like a parabola at -4. And it's like a straight line cutting through at x is 4. So we've got to decide, Bart, which way does it bounce? Look, do you think this is a positive cubic? When you multiply the x by the x squared, will you get positive x cubed? You will. Or when you multiply this x, that x, and that x, you get positive x cubed. It is a positive cubic. It'll look like this. So I can already guess that it's going to bounce like that. But, so we've got a bounce, a double root. This is what we call a double root at x is -4 and a single root at x is 4. But how do I know it goes that way? What would be the easiest way to double check apart from me knowing that? Sub x is -5. So just put -5 in here and you square it. Well, it's going to be positive. And if you put -5 in here, do you get what I'm doing? So, or -5 there, -5 there, -5 there. I get a negative times a negative times a negative. 3 negatives, minus, 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 is a negative. Yes, it starts down there. So we get the bounce there and back up. So that's what that looks like. Okay, domain. Cubics have no restrictions. All real x, range, all real y. All good? Now, while you're waiting, I'll write the next one out. G of x over f of x. Now, and then we're going to do f of x over g of x. Now, they're very similar, but we have to simplify them to be able to draw them. So x squared minus 16 over x plus 4. See what we did here before? Good idea to do it again. What does that equal? X plus 4, x minus 4 over x plus 4. I'm going to put the x plus 4 in brackets. What do you think cancels? See, I've got bracket times bracket divided by bracket. Yep, the x plus 4's cancel. So that function is actually the line y equals x minus 4, but there is a restriction. Have a look at the original function. X plus 4 can't equal 0. So this is actually a straight line graph, but x can't, with a hole in it. So I know that x plus 4 cannot equal 0, therefore x cannot equal -4. So what my function is the line y equals x minus 4 with a hole in it at -4. So I'm going to draw it. Are we okay, girls, or not? So I've got y equals x minus 4. It actually looks like this. Because, you know, the gradient's 1. It'll cut there and there. So when x is 4, so this is the function. Y equals x minus 4, but I know that x can't equal -4. That's my function. Wait a sec. Sorry. So when this is the function, so when x is 4, y is 0. When x is 0, y is -4. All right, I'm coming here. I've got to put a big hole in it. A hole, open hole, please. And lines continued on either end. That's an open hole. What is this value? -4 what? So there's an open hole. When x is -4, what's y? When x is -4, when x is -4, y is -4 minus 4, which is -8. Even though it's not allowed, that value doesn't exist, but you have to put an open hole around it. So you've got a hole in the graph, but that's where the hole would be. Because if I did -4.01, you'd probably get -8.00 something. All right, so you still can substitute that value in to here, so you can't sub it in there. But the simplified version allows you to substitute into it, which gives you, so you can't substitute x is -4 here, you get undefined. But when you factorize the numerator and do cancelling and end up with your new function, So this is actually a straight line graph with a hole in it. That's how you do the equation of a straight line graph with a hole in it. So this is my new function. See that? It's simplified to x minus 4. So g of x over f of x is actually a straight line graph. But according to this, there's a hole in it at x is negative 4. So when x is negative 4, I'm trying to work out the y value. That's right. But I'm substituting x is negative 4 into here now. Yeah, I know. I am all right. So x plus 4 can't equal 0. X can't equal negative 4. Sorry. So your function is x minus 4, but it's not just the x minus 4 graph. It's got a hole in it, but where x can't equal negative 4 or but x can't equal negative 4. So I need to know, I know my graph goes like this. I need to know what this value here is because it's going to help me with my range. So when x is negative 4, I can substitute it into this. I get y is negative 8. So therefore, what's my domain? Look at the graph. What's my domain? All real x, comma, x can't equal negative 4. And what's my range? All real y, y can't equal negative 8. Function of x over g of x. Now, similar, do the same thing. Let's go. This is like it's, all right, what's this curve? All right, no. What did we do before we factorized? We're going to do it again. Go. So that's x plus 4 over x plus 4, x minus 4. What cancels? So this is really the graph of 1 over x minus 4, but it's not just that graph. It has an extra hole. If I wanted that graph, I would just write that equation. It does look like that, but it's that with a hole in it. Let's see where the hole is. We know there already is an asymptote, but there's an asymptote and a hole in this. So tell me what x can't equal here. X squared minus 16 cannot equal 0. X squared cannot equal 16. X cannot equal plus or minus 4. Got it? Or I could have written it as x minus 4 brackets, x plus 4 equals 0, and said x can't equal 4 or negative 4 that way. So what you're going to do, you need to sketch this. What is this? It's a hyperbola asymptote at 4. Which quadrants? 1 and 3, and I'm going to draw it, but something's going to happen. We've got a hole somewhere. Where's the other hole? So I've got a hole at 4, which I've got, and just here I put another hole and just keep going. But I need to know what that value is. So that's negative 4 comma, and if you substitute in here, you'll be able to get the value. Negative 1/8. Are we okay? So when x is negative 4, y is 1 over negative 4 minus 4, which is negative 1/8, if I'm looking at this graph. Because that's the simplified version of the graph with a hole in it. Because this up here, the original equation is telling me there's a hole in it. So, all right, there's your curve. Now that we know what the curve is, we can say what the domain and range is. So the domain and the range. Oh, the domain's got a few pieces. Well, you could say all real x can't equal negative 4 and 4. If you want. I can't see why not. All real x cannot equal plus or minus 4. Or if you want to do the old method, it's negative infinity to negative 4 to 4, and 4 to infinity. If you're going to do it in 3 sections, but do you want me to write the 3-section one? The 3 sections would be from negative infinity to 4, union 4 to, negative infinity to negative 4, negative 4 to 4, and 4 to, 4 to infinity. Jeez. Can you see? Negative infinity to 4, negative 4 to 4, 4 to infinity. Really easy to mess up with that method. And what's the range? Look up and down. Y, comma, y can't equal 0. Oh. Yeah, y can't equal 0. Y cannot equal -1/8. Very good. And if you want to do it with their method, oh dear, going from bottom to top, wouldn't it be -∞ to -1/8 union, -1/8 up to 0, union 0 to infinity?